Hello everyone, Mr. Fawcett here, and we are back for another AP Calculus AB lesson. Today we're going to continue with the chain rule, but we are going to focus more so on the natural exponential function, so e to the x, and the natural log function, so ln of x. We're also going to do something pretty cool where I show you how to take a derivative on your calculator. So we'll get into more of it later, but it is a shortcut that can save you quite a bit of time both on classwork problems, but also on the AP exam if it is a calculator section. So we'll get there in a bit. Before we get there though, I want to see if you can apply the chain rule to the natural exponential and log functions on your own. So look at numbers 1 and 2. Try to apply the chain rule, pause the video, and then come back when you think you've made a good effort. Okay, so let's start off with number 1. Our inside function here is going to be 4 sine of x. Okay, so that's our inside. And we can call, again, you can call that c if you want. And our outside would be the entire thing. So if I'm trying to find the derivative of f of x, I get f prime is equal to the derivative of my outside function, e to the, and again, we could simplify this to e to the power of c if we wanted to, just to make things simpler. The derivative of e to the c is just itself, right? It's e to the c. So I get e to the c or e to the 4 times sine of x, because that's what c equals. So you can do that now, or you can do that substitution later, times the derivative of the inside. So times the derivative of 4 sine of x, which is equal to 4 times cosine of x. And then if you want to, you can rearrange this, but we are done. We do have a final answer. There's no more true simplifying that can be done. So we end up getting 4. I'll just write the cosine of x in front. 4 cosine of x times e to the power of 4 sine of x. Okay. Now we're on to number 2. So again, let's identify our inside function. So we have our inside function here. Again, we'll just call that c. You don't have to go through this process of, calling the inside function c. I just think it helps make a little more sense what the derivative of our outside function is. So the entire thing is our outside function. And we could just call that natural log of c. So if I'm starting to take my derivative, well, I get f prime of x is equal to the derivative of my outside. The derivative of the natural log of c is equal to 1 over c, or 1 over x squared minus 4, again, because that's what c equals, times the derivative of my inside. The derivative of x squared minus 4 is just going to be equal to 2x. So this one I can simplify for sure. So I get f prime of x is equal to 2x divided by the quantity x squared minus 4. And those are our two derivatives. So again, not learning really anything new. We just haven't applied the chain rule yet, at least I don't think we have, to the natural exponential and the natural log function. Let's scroll down. Let's look at these two boxes. Again, nothing new is going to go here. We're just applying an old rule to functions we've talked about before. If we are taking the derivative of an exponential function, the natural exponential function, well, we know that that derivative's the same, right? So it's e to the power of f of x. But now we actually have something other than x in our exponent. So we have to take the derivative of the inside function. So we get times f prime of x. And here's the interesting thing, guys. You've actually been applying the chain rule. You just haven't realized it. When we took our derivatives before, right, I might give you something like take the derivative of, with respect to x, of e to the x. Well, if we apply the chain rule here, my outside function is e to the x, or e to the c, so I get e to the x. My inside function is x, and the derivative of x is just 1, so times 1, which is, of course, just equal to e to the x. So we just haven't worked with a natural exponential function where the inside function has been something other than x, right? But the chain rule still is applicable there. We just didn't need to use the chain rule because the inside function had a derivative of 1. But I wanted you to see that there was a connection there between what we were doing before. You just didn't know that we were using the chain rule because we hadn't learned it yet. Let's jump down here to a natural log function. It's the same thing up top. We've been using the chain rule for a natural log function before, but the only examples we had done were natural log of x. Once we have something other than x inside of our natural log function, well, again, we still take the derivative of the outside, so 1 over f of x, times the derivative of the inside, which is the derivative of f of x, so times f prime of x. And we can simplify here. So we get f prime of x over f of x. We'll circle this one up here as well, or box it. Now, again, these are not formulas I want you to just memorize, right? I want you to understand where they come from. If you just memorize these two formulas for the derivatives, you're not really understanding what the chain rule is. And these didn't take very long to think about when it came to the chain rule. We were able to work those out pretty easily. So when you're doing the chain rule, again, you just want to think about what's my outside function, what's my inside function, and then you start by taking the derivative of the outside function and then gradually work your way into the innermost function. Right here, we only had two functions, so there was just outside and inside. As looked at in the previous lesson, or 2 lessons ago, we've had functions that have 3 functions, right? There's an outside, there's a middle, and there's an innermost function. And we could even extend that to 4, 5, 6, etc. functions. All we have to remember is start with the derivative of the outside, then work your way into the innermost function. Okay, let's do some practice. We are going to do numbers 3 and 6. 3 and 6. Let's make this a little bigger. And as always, I would encourage you to attempt the problems on your own first and then look back for a solution. So for number 3, we only have one rule to use, just the chain rule. My inside function is my cosine of x. My outside, of course, is e to the x, or e to the c in this case. Depends if you want to call cosine of x c. So when I take the derivative, I get f prime of x is equal to the derivative of the outside function. And whenever we have an exponential, natural exponential function, it's the same, times the derivative of the inside. So times the derivative of cosine of x, which is negative sine of x. So f prime of x is equal to negative sine of x times e to the power of cosine of x. It doesn't matter what order you have those functions in because they're a product. All right, let's move on to number 6. Number 6 is a little bit more challenging because we have a product as well as a chain rule. Here's one function. Here's my other one, and we have a product rule. So we're not worried about number 5. So I'm going to start over here. I've got, you know what, I'll just do it below. I'll use that space for something else. So I get f prime of x is equal to the derivative of the first function. So the derivative of the blue function is just 4 times my second function, which is e to the power of 3x, plus my first function, so quantity 4x minus 5, times the derivative of my second. Now here's where the chain rule comes in, right? If I have the function e to the power of 3x, my inside function is 3x, and my outside function is e. So the derivative of my outside function, right, is just e to the power of 3x. Derivative of my inside function is just 3. Derivative of 3x is 3. Now I just have to do some simplifying. And there is a decent amount we can do here. So I get f prime of x is equal to, well, I'm going to keep my first term the same. Then I'm just going to move the 3. So I'm going to do plus 3. I'm going to put the e to the x, e to the 3x first, and then have 4x minus 5 over there. And again, this would be an acceptable answer, but another way you may see it is them having factored out the e to the power of 3x. So if they do that, we'd get f prime of x is equal to e to the power of 3x times the quantity 4 plus 3 times the quantity 4x minus 5. We could actually go further and continue to simplify. I'll just write it over here. So I get f prime of x is equal to e to the power of 3x. I'm going to skip some steps here. So I'm going to get 12x minus 11. And you can check my distributed and simplifying. But that's what we should end up with if we are fully simplified. That's probably the answer you'd see on a multiple choice test. All right, let's do one more. Let's choose one with the natural log function. And let's do number 13. Double chain rule for 13. So that one should be interesting. Okay, again, I'd pause the video, see if you can work this one out by yourself, and then come back and join us. Okay, so here's the thing. I'm going to rewrite f of x first, just so that you can see everything that's going on. So I have f of x is equal to, instead of the radical, I'm going to write that as an exponent. So I'll get natural log of the quantity 2x minus 4 to the power of 1/2. Now, you have some options here. You could first realize that through log properties, this can be written another way as 1/2 natural log of the quantity 2x minus 4. And this actually ends up being the easiest way to complete the problem. When I first saw this problem, I initially thought double chain rule, but using this log property, we're able to bypass that. So instead of having to deal with the chain rule of the quantity 2x minus 4 to the power of 1/2, if we bring that 1/2 out as a coefficient, we suddenly don't have a chain rule inside of our natural log function. We just have a 2x minus 4, which would be a simple power rule. So we still do have one chain rule though, right? So I identify the inner function, or the inside function. You got to identify the outside function. And then we start with our chain rule. So derivative of f prime, or sorry, derivative of f is f prime. The 1/2 stays where it's at. The derivative of natural log is going to be 1 over everything inside, so 1 over 2x minus 4, times the derivative of the inside, which ends up just being 2. So f prime of x is equal to 1 over the quantity 2x minus 4. So actually a pretty simple problem if you understand that log property of taking the exponent on the input of the natural log and moving it out as the coefficient. If you didn't recognize that, then you would have a double chain rule to complete. Let me just show you real quick what that would look like, and then you can decide which looks easier. Okay, we're going to stop there for part 1. We will be back for a part 2 with some more practice problems to review. As always, enjoy the rest of your day, and I look forward to seeing you back here next time. Okay, and I am going to go through all the steps here just because otherwise I think you may get a little confused. So we're going to have to start with this right here. Okay, my inside function, so inside would be my 2x minus 4, and I'm going to let c represent that. My middle function would be c to the power of 1/2. Okay, and I'm just going to let that be represented by b. And then my outside function would just be my natural log. So my outside function would be the natural log of b. Now we got to work our way from the outside all the way to the inside. So here we go. Let's hope I have enough room. F prime of x is equal to the derivative of the outside, which is 1 over b. We'll substitute in later, times the derivative of the middle function, which would be 1/2 c to the power of negative 1/2, times the derivative of the inside, which is equal to 2. Now I got to do some substituting. First, I'm going to simplify my 1/2 and 2. So I get f prime of x is equal to 1 over b. These simplify, and I get times c to the power of negative 1/2. I now am going to rewrite c with both a positive exponent and a radical symbol. So I get f prime of x is equal to 1 over b times 1 over c to the power of 1/2, which means I get f prime of x is equal to 1 over b times 1 over the square root of c. And then I substitute in for b and c, and I get f prime of x is equal to 1 over b, which is really c to the power of 1/2, times 1 over, you know what, I'm actually going to keep this as c to the power of 1/2 because it'll make sense. Now, if I multiply my c to the power of 1/2 times c to the power of 1/2, I get 1 over c, which is equal to 1 over 2x minus 4, which is what we got over here. It just took us a lot more steps. So sometimes it's fun to do a problem 2 different ways, just to kind of prove to yourself that you can, solve the problem regardless of what's thrown at you or what way you're asked to do it. If you had forgotten that log property, you would have to do it the way we did it over here on the left, right? But you still can do it as long as you remember what the chain rule process is and keep your function straight. But if you remember that log property, then your path to success is much shorter. but there is still a chain rule to apply. So again, you can always pause the video, go back, re-look at the algebra, the simplifying, etc., to make sure that you understand each and every part.